Imagine you could move so fast that the universe stopped aging. You look at your watch and the second hand is frozen. You look outside and galaxies have ceased to spin. This sounds like pure science fiction, but it is actually a mathematical prediction of relativity. There is a specific speed where the concept of duration collapses. We're told that light travels at this speed, covering vast distances from the Big Bang to your eye. But here is the question that breaks the human mind. If time stops at the speed of light, does a photon actually exist in time at all? Does it arrive the exact instant it was born? The answer requires us to dismantle our intuition and look at the raw geometry of the universe. Because what happens at light speed isn't just about going fast, it is about the fundamental structure of reality itself.
We live our lives in a world of low velocities. If you want to go faster, you just add more energy. Push the gas pedal harder and the car accelerates. But the universe has a strict bill collector. As you approach the cosmic speed limit, the cost of acceleration begins to spike dramatically. Einstein revealed that mass and energy are interchangeable. So as you pump energy into an object to speed it up, you are effectively adding to its relativistic mass. It becomes heavier and harder to push. To actually reach the speed of light, a massive object would require infinite energy. This is why you can never truly be a photon. You are trapped in the realm of the slow and massive. But we can get very, very close. And when we do, the flow of time begins to warp. This isn't just a theory on a chalkboard. We deal with this reality every single day.
Consider the GPS satellites orbiting Earth right now. They are moving much faster than you are, roughly 14,000 kilometers per hour. According to Special Relativity, their high speed makes their onboard clocks tick slower by about 7 microseconds per day compared to clocks on Earth. But gravity also plays a role here. Farther from Earth's mass, gravity is weaker, which actually speeds time up by 45 microseconds a day. When you combine these effects, there is a net drift of roughly 38 microseconds every day. That might sound like a meaningless fraction of a blink, but light travels incredibly fast. If engineers didn't correct for that tiny time drift, your GPS accuracy would degrade by over 10 kilometers daily. The system would be useless within minutes. So we know for a fact that velocity impacts time. But what happens if we push that to the absolute limit? Let's look at the universe from the perspective of geometry. In our 4D spacetime, we measure distance with a metric. For you and me, the distance between two events is real. We age as we travel from point A to point B. Our biological clocks tick forward. We experience the passage of time as a positive value. But light travels on what physicists call a null geodesic. If you calculate the spacetime interval for a photon, the math returns a value of exactly 0. This is the source of the claim that time stops. Mathematically, the proper time along a light beam is 0. This implies something absolutely wild about our reality. For a photon emitted by a star a billion years ago, the journey to your telescope takes no time at all. The emission and the absorption are geometrically touching. The photon is born and dies in the same instant. It doesn't experience the passage of time that we measure. To the photon, the universe is incredibly intimate.
However, we have to be extremely careful here. It is tempting to say, from the photon's perspective, but modern physics tells us this is a trap. A perspective implies a valid reference frame. It implies you can place a camera on a particle and watch the universe go by. But you cannot pin a coordinate system to a photon. If you tried to travel at light speed, the equations of relativity would divide by 0. You essentially break the mathematics of the universe. So while the interval is 0, the photon doesn't have a perspective or an experience. It is better to think of light not as a traveler, but as a connecting wire in the circuit of spacetime. It binds two events together without the friction of time. This leads us to a terrifying question about free will. If light connects the past and future instantly, is the future already written? This brings us to the block universe theory. Since time is relative to your speed, there is no single now that everyone agrees on. Your now might be different from an alien's now. If you move relative to the Andromeda galaxy, your slice of now could sweep millions of years into their past. If different observers can't agree on what is happening now, then the past, present, and future must all exist equally. Think of the universe like a loaf of bread. We are just slicing it at different angles, but the whole loaf exists at once. This view is known as eternalism. In this model, the dinosaurs are still alive in the past. Your great-grandchildren are already born in the future. The entire history of the cosmos is a static 4D structure. Recent cosmological work in 2025 supports this view, suggesting it solves paradoxes regarding black holes. If all information is preserved in the block, nothing is truly lost.
But there is a new contender in the ring. Recent studies in 2024 have revitalized a strange idea. What if time isn't fundamental at all? This is known as the Page-Wootters mechanism. It suggests that time emerges from quantum entanglement. Imagine the universe is a static, timeless system. But if you split it into two parts, and those parts are entangled with each other, one part acts as a clock for the other. To an observer inside the system, it looks like time is flowing. But to an observer outside the universe, nothing changes. It's like a movie reel sitting on a shelf. The movie isn't playing, the reel is static, but for the characters inside the frames, there is a story. Experiments with toy models have confirmed this effect. We can create systems that look static from the outside, but have dynamic evolution on the inside.
So does time exist at light speed? The answer is a paradox. For the light itself, the journey is instantaneous. The geometric distance is zero. But for us, the watchers, the journey is long and real. We are trapped in the slow lane of the universe. And perhaps that is a good thing. It is our inability to reach light speed that gives us the luxury of a past, a present, and a future. Time might be an illusion of our mass, or a trick of quantum entanglement, but it is the only thing that keeps everything from happening at once.